Our universe is amazing. What is even more amazing is just how little people know about the various astral bodies that exist within it and how they formed. Hello, my name is Stephen Cardis, and today I hope to provide you with information about the wonders just above our heads, or below our feet, or to the sides of us. You get the point. I will take you on a short tour of the observable chunk of our universe, through time, beginning with theories on the formation of certain bodies, and then moving into facts about current observable bodies, and finally theories on what will occur in the future. The most obvious place to begin is the beginning of everything. I don't have enough time to describe in detail the Big Bang, but I will instead fast forward through it a little. After the Big Bang, the universe was comprised of subatomic particles and radiation. It is unknown whether these particles combined over time due to gravity to create stars and eventually galaxies, or if the universe instead organized into immense clumps of matter that later subdivided into galaxies. However, by one of these theories, our galaxy, the Milky Way, was created. Our galaxy is relatively young, containing many new stars and plenty of dust and dark matter to create new ones. Compared to other galaxies, it is mid-sized, giving it the spiral shape, unlike the ancient IC 1101, which is in an orbital shape. It is in an orbital shape due to billions of years of colliding with other galaxies and absorbing them. Our solar system is just a speck within our galaxy, surrounding just one of millions of stars. But how did our sun come into being? Our sun, like other stars, was formed in a nebula, a massive interstellar cloud of dust, plasma, and mostly hydrogen gas. And I mean massive. We're talking thousands of light years in length and width. In spiral galaxies like ours, these stellar nurseries are abundant. Inside the nebula, dense parts of the clouds undergo gravitational collapse and compress, forming a rotating gas globule. The globule is cooled by emitting radio waves and infrared radiation. It is compressed by gravitational forces and also by shock waves of pressure from supernova or the hot gas released from nearby bright stars. These forces cause the roughly spherical globule to collapse and rotate. The process of collapse takes between 10,000 to 1 million years. The contracting cloud heats up due to friction and forms a glowing protostar. This stage lasts for roughly 50 million years. If there is enough material in the protostar, the cycle of gravitational collapse and heating continue. When a temperature of about 27 million degrees Fahrenheit is reached, nuclear fusion begins at the core of the sun. This is the nuclear reaction in which hydrogen atoms are converted to helium atoms plus energy. This energy, also known as radiation production, prevents further contraction of the sun. Another name for this energy is sunlight. The sun then stabilizes and becomes a yellow dwarf, a main sequence star, which it will remain in this state for most of its life, averaging around 10 billion years. Our sun is currently a yellow dwarf that is approximately 7.5 billion years old. Also contained inside nebula are asteroids and other debris. This debris gets caught in the gravitational pull of the new sun and over time collides to form terrestrial planets like our Earth. Gas giants like Jupiter and Neptune are the collections of leftover gases and dust from the nebulae that collect around a small core. Planets forming around suns is expected, however moons are not so easily formed. Scientists are still not even sure how our moon came to be, but they have a few theories. First is the co-formation theory, in which it is theorized that the moon developed at the same time as the Earth from the same debris. At the same time gravity was drawing the Earth together, the moon was also being drawn together and fell into the Earth's orbit. However, the Earth and moon have different compositions, which shouldn't be the case if they developed at the same time from the same material. Secondly is the capture theory, in which it is theorized that the moon was a passing body that was grabbed by the Earth's gravity and pulled it into its orbit. This would explain the different compositions of the Earth and moon. However, bodies like these are often oddly shaped and not spherical. For example, Phoebe, one of Jupiter's 67 moons, that looks more like an asteroid than a moon as we know it. Finally, we have the giant impact theory, which is the prevailing theory within the scientific community. This theory states that shortly after the Earth was formed from debris around the new Sun, another Mars-sized protoplanet, named Theia, collided with Earth. The light debris from Earth's crust compacted around Theia's remaining core, creating a moon centered on Earth's ecliptic plane in line with the Sun, and the largest in the solar system relative to its host planet. From Earth, the moon is pretty easy to spot. If you haven't seen it yet, just look up, it's like right there. What you may not see with the naked eye are things like star clusters, nebulae, and even hundreds of distant planets. Well, what exactly are star clusters? As I've just gone over, stars are born within nebulae. Nebulae are composed of hundreds of solar masses of material, so naturally they spawn clusters of many stars. After the remnant gas is heated and blown away, the stars collect together due to gravity. During the exchange of energy between the stars, some stars reach escape velocity from this protocluster and become runaway stars, or shooting stars. The rest become gravitationally bound, meaning they will exist as a collection orbiting each other forever. These clusters are incredible. The brightest parts of them even make up some of the constellations in our own night sky. Messier 13, a massive globular star cluster containing approximately 300,000 stars, is located in the constellation of Hercules, 25,000 light-years away. Messier 13, and all stars in the universe, originated from nebulae. However, before nebulae even spawn stars, they themselves are some of the most intricate and breathtaking bodies in the universe. Two famous nebulae are the Crab Nebulae, which formed after a supernova, and the Eagle Nebula, which is in the process of creating new stars. The Eagle Nebula contains one of the most famous discoveries in the history of astronomy, the Pillars of Creation. These massive pillars of gas were given their name due to the fact that they are in the process of creating new stars. The leftmost pillar is approximately 4,000 light-years in length, with the small finger-like protrusions at the top being larger than our own solar system. The many vibrant colors you see are caused by varying temperatures, gases, plasma, and radiation. Different levels and combination of these things result in different colors. With all this radiation, gas, extremely hot temperatures, exploding stars and debris hurtling through space, it's hard to believe our planet can sustain life. Or is it? It seems apparent that Earth is the only life-sustaining planet within our solar system from what we can tell, and the only one for thousands of light-years too. However, modern technology has allowed us to probe deep into space farther than ever before. We found thousands of planets, believe it or not, and dozens seem to be habitable. The Earth Similarity Index rates distant exoplanets on multiple criteria relative to Earth to determine if they could sustain life. So far, thousands of exoplanets have been discovered with the assistance of the Hubble Space Telescope, with hundreds being within their star's habitable zone and possibly suitable for life. One such planet is KOI 1686.01. Ranking number 1 on the Earth Similarity Index, it is currently the most habitable planet due to date. It has a radius 1.33 times that of Earth and is believed to be covered in large amounts of liquid water. It has been dubbed a super Earth. And who knows, with future technology, distant space travel might become possible, and we might just be able to evacuate this planet before it is destroyed. Now don't worry, that certainly won't happen for billions of years, and our distant great hundreds of greats grandchildren will have plenty of spectacular astral sights to see before our planet's demise. One such happening will be the explosion of the star Betelgeuse in a brilliant supernova. Betelgeuse's diameter fluctuates between 550 and 920 times our Sun's as it nears the end of its life. In about 1 million years, it will finally explode, and when it does, for about 2 weeks the Earth will appear to have 2 suns. The light from it will shine brighter than the full moon at night and will even be visible during the day. Now that will be an incredible sight to behold, yet it pales into comparison to what will happen in about 3.75 billion years. This is the Andromeda Galaxy. It is located 2.5 million light-years away and contains twice as many stars as the Milky Way, and it's headed right for us. Traveling at 300 kilometers per second, faster than a speeding bullet, Andromeda will collide with our galaxy in a spectacular display of colors, making Earth's sky look like a sci-fi Martian world. The collision, as shown in the simulation, will form a merged, larger galaxy of reddish stars called the Andromeda. Seemingly miraculously, our solar system should survive because galaxies are mostly empty space. Unfortunately, nobody will be around to see it because by that time our Earth will resemble Venus. You just click it down. With dried up oceans and a boiling hot surface with lots of volcanic activity as a result of our sun heating up as it dies. About 6 billion years from now, our sun will run out of hydrogen reserves to fuel the fusion keeping it alive, and it will begin to cool down. As it cools, as we all know, when things cool, they expand. And as it cools, it will expand, becoming a red giant, and destroy the inner planets of the solar system, Earth included. By now I hope you would agree that our universe is truly amazing. There's so much out there to see, from star clusters to nebulae, to the most distant planets beyond our galaxy. And so much more to learn about the processes that created them. And we have all the time in the world to observe them before our sun dies and roasts our planet alive. I hope this was informative and entertaining. Thank you.
Oh, sure, of course, anytime.
Have a good rest of class.
Thanks. Have a good day. How long was that, Jimmy?
11 minutes and 44 seconds.
Was it really?
Huh? Okay, Jasmine, we have time. Who else needs to go? Just you?
I'll go next time.
You'll go next time. Megan, you want to go now or you want to wait?
Yeah, we go over too.
We have about 8 minutes, 7 minutes. Do you want to go? I would. You're dressed up.
I was like spamming it.
Dilo, you needed to hit from current slide.
Yes, Wolf.
Sorry, Michelle, I don't know.
No, it's okay. No, you know what? It's okay because things happen. It's a good lesson.
I've never used like that.
Plus, Steven didn't miss a beat. It was fine. He handled it well. That's what we're looking for.
Like in the old version.
Oh my gosh, we're still recording.